Hello students, let us start our second class on determinant. Today we shall introduce the concept of minor, cofactor and some properties of determinant and also properties of minor and cofactors. First we see what is minor. The minor of an element in a determinant is the determinant of next lower order obtained by deleting or omitting the row and the column in which that element occurs. For example, in this determinant, if we want to find the minor of B1, B1 lies in first row and second column. So omit first row and second column. What we get? A2, C2, A3, C3. See, this is written. Minor of B1 is the second order determinant A2, C2, A3, C3. The value we can calculate A2C3 minus A3C2. Then cofactor. The cofactor of an element in a determinant is the coefficient of that element in the expansion of the determinant with respect to the elements of the row or column in which that element occurs. For example, in this determinant, if we expand, we get this expansion. Already in the first class we have seen this is the expansion of the determinant with respect to elements of first row. Slightly modified way we have written here, taking this A1, B1, C1 to the right side so that coefficients of A1, B1, C1 can be easily written. Here, cofactor of A1 is this determinant. Why? See, cofactor of A1 is this determinant, so this is cofactor of A1. Now, what is the coefficient of B1? This determinant with a minus sign, so cofactor of B1 is minus of this determinant. This is cofactor of C1. Coefficient of C1 is this, that's why it is cofactor of C1. Now these cofactors are also minors. We have seen these are the minors but with proper sign, because for A1 and C1 the cofactors and minors are same, but for B1 cofactor is negative of the minor of B1. Thus the cofactor of an element in a determinant is the minor of that element with proper sign prefixed. That is important. Now how to prefix the sign? If the element lies in ith row and jth column, then its cofactor is given by minus 1 to the power I plus j into its minor. This minus 1 to the power I plus j prefixes the sign. So cofactor depends on position of the element also. Now if I plus j is even, then cofactor is same as the minor, because minus 1 to the power I plus j will be 1. And if I plus j is odd, then this minus 1 to the power I plus j will become minus 1. That means cofactor will become negative of minors. So cofactors are minors with proper sign. This is justified. Now in this example we shall calculate. Suppose cofactor of A1 we want to find. Where A1 lies? A1 lies in first row and first column. That's why minus 1 to the power 1 plus 1. And then minor of A1 is omitting first row and first column. We get this determinant. So this is cofactor of A1. Incidentally, this is same as minor of A1, because minus 1 to the power 1 plus 1 is 1. Now minor of B3 is omitting third row and second column, because B3 lies in third row second column. So what we get? A1 C1, A2 C2. This is the minor of B3. Value is this. Now if we want to write the cofactor of B3, then we have to prefix this minus 1 to the power 3 plus 2 into minor of B3. So in this case what we see, this is the negative of minor. Cofactor of B3 is negative of minor, and cofactor of A1 is same as minor of A1. Similarly, if cofactor of any other element we can calculate. Sometimes it will be same as minor, sometimes it will be minor with minus sign. Practical example, let us see here. Cofactor of minus 8 in this determinant. Minus 8 lies in third row second column, so minus 1 to the power 3 plus 2. Then minor of 8 is omitting third row and second column. We get minus 1, 3, 4, 6. So we have calculated as usual. This is cofactor of minus 8. Now cofactor of 0. 0 lies in second row, second column. So minus 1 to the power 2 plus 2. That will be plus 1. And then minus 1, 3, minus 7, 9 remains. This is minor of 0. Finally, cofactor and minor are same for this element. Special case, let us consider this second order determinant. Cofactor of minus 1. Minus 1 lies in first row and first column. So minus 1 to the power 1 plus 1. Now omit first row, first column. What you get? We get only one element. That element also we have written within 2 vertical lines. This is determinant of order 1 and it is 0. Determinant of order 1 value will be same as the element with which we have constructed the determinant. Cofactor of 2 suppose we want to find. Then it is 2 lies in first row second column. So minus 1 to the power 1 plus 2. And then remaining element after cancelling first row and second column we get 4. So this is determinant of 4. So it is 4 but there is a minus sign in front, so it is minus 4. Cofactor of 0 if we want to find. The 0 lies in second row second column, so minus 1 to the power 2 plus 2 plus 1. And then interesting here, determinant of this single element minus 1 is also minus 1. Here we should note this determinant of minus 1 is minus 1. It is not modulus of minus 1. Not modulus of minus 1. Although notations are same. That means determinant of order 1 is the element itself. We can remember this. Here we should read it determinant 1 by 1 determinant or determinant of order 1 is equal to the element with which it is constructed. It is not mod A equal to A like that. And it will be of course less. We shall use less. Second order, third order, etc. we shall use more. Now introduction of some notations. In general, small letters A1, B1, C1, etc. are used to denote elements of a determinant, that is numbers or functions like that. And their cofactors will be denoted by corresponding capital letters. Cofactor of small a1 is capital 1. Cofactor of small b1 is capital 1, like that. This is convention. Now let us see some properties of cofactors. Let d equal to this determinant. Means with this determinant when expand we get a value, that value is d. But as usual we have expanded this determinant in the right side. We know from the first class this is the expansion with respect to elements of first row. Now slightly modified way we have written here a1 into a1 determinant plus b1 into another determinant, second order determinant with minus sign plus c1 into another determinant. Incidentally, this determinant a1 into this determinant is actually cofactor of a1 because these are the coefficients of a1, b1, c1 in this expansion. So this is cofactor of small a1. This is with minus sign. This determinant with minus sign is the cofactor of b1. So it is plus small b1 into capital B1. Here we have written. Then this is cofactor of small c1. So it is small c1 into capital C1. So what do we see? Small a1, b1, c1 are elements of first row and capital A1, b1, c1 are cofactors of elements of first row and their sum product is equal to value of the determinant. So thus we get one property, rather we have proved this property, and this we write here. There are 6 results. Roman 1 is already proved and others can similarly be proved. Roman 2, let us see what is Roman 2 here. Here small a2, b2, c2 are elements of second row and capital A2, B2, C2 are cofactors of elements of second row, means same row we have considered. So the value is D. Similarly Roman 3 also. And in Roman 4 what we see, small a1, a2, a3 are elements in the first column and capital A1, A2, A3 are cofactors of the elements in the first column. Same column, and the sum product is value of the determinant. Similarly number 5, number 6 with second column, this is with third column. Thus, in short, we can say this: the sum of the products of the elements of any row, or you can take column, with corresponding cofactors of the elements of the same row, any row and same row here. If you take column, you have to take column, is equal to the value of the determinant. So these are the properties, 6 properties, all equal to value of the determinant. Sum product of the elements of a row with corresponding cofactors, or sum product of the elements of the elements of a column with corresponding cofactors, that is equal to D, value of the determinant. But if we calculate this value of this expression, here small a2, b2, c2 are elements in the second row, but capital A1, b1, c1 are cofactors of the elements in the first row. We have substituted the values that we know already. So these values substituted, and we can expand this second order determinant, the b2 c3 minus b3 c2, a2 c3 minus a3 c2, a2 b3 minus a3 b2. These are written here and then multiplied and we see that all terms gets cancelled. This term a to b2 c3, a to b2 c3 cancels, this a to b3 c2, a to b3 c2 cancels, this term cancels with this term, so we get 0. So what we have seen, sum product of the elements of second row with cofactors of first row, the answer is 0. Thus we get many results here. Number 7 is proved. Number 8, if we see here, A3, B3, C3 are elements of third row, but capital A1, B1, C1 are cofactors of elements of first row. That's why sum product is 0. Similarly, up to 12. Then number 13, if we see, small a1, a2, a3 are elements in the first column, and capital B1, B2, B3 are cofactors of the elements in the second column. Sum product is 0. Similarly, others. So in short, we can say this: the sum of the products of the elements of any row with corresponding cofactors of elements of another row is equal to 0. Same thing true for column. Sum of the products of the elements of any column with corresponding cofactors of the elements of another column is equal to 0. So many zeros are there. So these are the important properties we have to remember. Two sentences rather. Now we note this: value of this expression cannot be ascertained without detailed calculation. Question is why? Here small a1, b1, c1 are elements of first row, but capital B1, B2, B3 are cofactors of elements of second column, means row column mixture. So there is no such result above we have seen. Row with row, column with column. Here it is row and column mixed. So without actually knowing the value of capital B1, B2, B3 or putting and then simplifying, we can only calculate. Properties of determinant. Now we see. The value of a determinant remains unchanged if the rows are written as columns in the same order. Important, in the same order. This is the determinant. Usually we write. Now what we have done here: first row written as first column, second row written as second column, third row written as third column. The both sides are same. This property is obvious because a determinant can be expanded with respect to any row or any column. Left side determinant, if I expand with respect to elements in the first row, we shall get a value, and right side determinant, if we expand with respect to elements in the first column, we shall get the same value because here first row and here first column same. So that's why the values are same. Number 2 property: the value of a determinant is 0 if all the elements in a row or column are zeros. This is very obvious. Reasoning is same as in Roman 1. Why? I can expand this determinant with respect to elements in the second row. So it will start with like that: minus 0 into second order determinant 0, plus 0 into second order determinant 0, minus 0 into second order determinant 0. Similarly here also I can expand the determinant with respect to elements in the first column, so everything will be 0. Nice property. We shall use many times this result. One note: while applying some elementary row or column operations such as adding rows, adding columns, etc. in a determinant, the ith row is usually denoted by ri, capital R suffix I, ri, ith row, and jth column is denoted by cj, capital C suffix j. R for row, C for column. We shall use it here in the property 3. The value of a determinant changes in sign only if any two rows or any two columns are interchanged in position. The value magnitude remains same, only plus will become minus, minus will become plus. For example, we see this determinant becomes minus this determinant. It is obtained by this operation. What is the operation? First column and second column interchanged. This is the symbol C1 double arrow C2, means C1 goes to the position of C2 and C2 comes to the position of C1. Here of course C1, C2 are column 1 and column 2, they represent. So minus sign. And here R1 double arrow R3 means first row goes to the position of third row and third row comes to the position of first row. See, this is there, and also one minus sign is to be given. Very obvious. You can expand right side. Obviously it will be same as expansion of left side with a minus sign only. So left as an exercise. Roman 4 property: the value of a determinant is 0 if any two rows or any two columns are identical. Nice property. If two rows become same or two columns become same, the value of the determinant will be 0. Very obvious, you can see from here. Here I have taken second row and third row same, and the value 0, R2 equal to R3. Here I have taken first column, second column same, value 0. I have taken first column, second column same, means C1 equal to C2. Now how? You can see, if I expand this determinant with respect to elements in the first row, then it will be x into BC minus BC 0, then minus y into AC minus AC 0, then Z plus Z into AB minus AB 0, all become 0 automatically. So this is a nice property. Two rows or two columns same, means answer is 0. Number 5 property. In a determinant, if each element in any row or column has a common factor, small m, say, then m is also a common factor of the corresponding determinant. How? Let us see this. This determinant, first row I have taken MA, MB, MC, means M is common to all the elements. So I can expand this with respect to elements in the first row. So it will be MA into one determinant, minus MB into another determinant, plus MC into another determinant. So MA into MB into MC. So that time obviously I can take common. So that's why this is the result. Similarly, here also from second column we can take common. Actually from any row, any column we can take common. This is also an important property for calculating, simplifying value of determinant we shall use. Property number 6. In a determinant, if each element in a row or in a column is a constant multiple or submultiple of the corresponding element of another row, then the value of the determinant is 0. If one row is double of another row, one column is triple of another column, then value of the determinant is 0. But what do you mean by submultiple? Means one column is 1/3 of another column, one row is half of another row. These are called submultiple. For example, this determinant, here second row is k times the first row. I have written here R2 equal to KR1, k times first row. That's why the value is 0. The reasoning is that after taking k common, the two rows become same, and only by a previous property the value is 0. As a practical example, if we want to find the value of this, what we note that first column is double of the second column. So I can take two common, first column, second column will be same, so the value is 0. So this is the reason you can say C1 equal to twice C2, first column equal to 2 into second column, that's why value is 0. So without expanding also, many times we can give the answer for a short question, value of the determinant, using the properties. Property number 7. In a determinant, if each element in a row or a column is the sum of two or more elements, then the determinant can be written as the sum of two or more determinants. See, we have taken this determinant here, where every element in the first row is the sum of two elements. Then this, from this we get two determinants. First determinant we have written with first elements A, B, C. Second determinant we have written with A, X, Y, Z. But second row and third row remaining as it is in both the determinants. This can be easily verified by expanding the left hand side of the determinant in the left hand side with respect to elements in the first row. Similarly, this determinant, here we have taken second column as the sum of two elements. Here also we have written this as sum of two determinants, where first column and third column are same in both the determinants. This can also be verified very easily by expanding the left side in the with respect to elements in the second column. Next we go to property number 8. This is the most important property. In a determinant, if each element in a row or column is increased or decreased by a constant multiple or submultiple of corresponding elements, important word always, corresponding elements of another row or column respectively. If you take row, here also, if you take column, here also column, then the value of the determinant remains the same. For example, this is the determinant. What action we have taken? R1 changed to, here we read it not tends to, changed to R1 plus KR2, means first row is replaced by first row plus K times second row, multiplying elements in the second row by K and added. The values of the two determinants are same. We have given the justification here. Right side we have written first row is the sum of two elements, so we can write this as the sum of two determinants by the previous property. Now here we see that in the second determinant, what we see that first row is K times the second row. So if I take K common, two rows are equal, so 0. That's why we have written here 0, means left side, right side, both are same. Therefore the property is proved here. Also similarly, this we can write using this operation. C3 changed to C3 plus K1 means third column we have changed by adding K times the first column. The value of the two determinants are same. Now if I take K equal to 1, then it is R1 plus R2 here. R1 plus R2. If I take K equal to 1, then it is C3 plus C1. If I take K equal to minus 1, then this becomes R1 minus R2, this becomes C3 minus C1. So in particular in a determinant, one row or column can be added to or subtracted from another row or column respectively, as the case may be, without changing the value of the determinant. That is, two rows can be added. Value of the determinant will not change. One row can be subtracted from another row. Value of the determinant will not change. One column can be added with another column. Value of the determinant will not change. That we shall use many times. This property shall be used frequently in simplifying or calculating the value of a determinant by shortcut method. So these are the properties of determinant, properties of cofactor we have learned today, and these are to be revised. See the video 2 times, 3 times if necessary, and then read the PDF also. Now let us see some examples. Find the value of the following determinant. This determinant, in the last class we have expanded it and got the value. Now this class, what we see? What we notice? Third row we notice that 2 is common. If I take 2 common from third row, what becomes? Third row becomes 1, 2, 3. Already first row is 1, 2, 3. So third row and first row are same. So the value of the determinant is 0. The reason we have written R1 equal to R3. This was also asked in 2010 with 1 mark. So shortcut using property you can find the value of determinant. Roman 2 example. So this determinant. First we have removed this all squares, written the proper values. Now this determinant we can expand, we can find the value, but let us find by shortcut method. What is the shortcut method? If we can bring 1 0 or 2 0 or 3 zeros in a row or column, then the value can easily be calculated. That's why what I have done, 4 minus 4 times of this 1 will be 0. That's how the operation I have written here. C2 changed to C2 minus 4C1 means second column minus 4 times first column, so that this element becomes 0. Then C3 third column changed to third column minus 9 times first column, so that this 9 will give us 0 here. 2 zeros we have got here, 2 zeros using these operations, and accordingly of course the other calculations we have done. You cannot apply operation to an element directly. You have to apply in a column or in a row. That means every element should be affected in a row or in a column. So we have got 2 zeros in the first row. Now we can expand this determinant with respect to elements in the first row. So 1 into minus 7 into minus 56, minus minus plus. That's why you have not given sign. Then minus, this is for minus of the formula. Minus 20 into minus 20. So this will be again minus minus plus, means I have written 20 into 20. So the value is very easily obtained, minus 8, because of these 2 zeros. So big numbers can be made 0 using the elementary operations, and value of the determinant can be obtained easily. So this is the note. We note that zeros brought in first row. Why? To minimize the work of calculation. You can bring in the first column or third column or third row, anything depending on of course numbers and question. Example Roman 3. This determinant we want to find the value, where omega is an imaginary cube root of unity. We have studied in class 11. Omega cube equal to 1 and 1 plus omega square 0. This is the property of omega. So we can expand this, we can find the value, but we see that if we add second column and third column with first column, that is C1 changed to C1 plus C2 plus C3. Second column, third column added with first column, this operation, then we see that every element in the first column becomes 1 plus omega square, and we know 1 plus omega square equal to 0. So 3 elements 0 in the same column, therefore value of the determinant is 0 by a property. So very easily we have found the value. Example Roman 4. See these big numbers in this example, but carefully we notice third row. From third row we can take common. What we can take common? Twice y. If I take twice y common, then third row becomes 11, 12, 13, but first row is already 11, 12, 13. So first and third row are same, R1 equal to R3 you can mention, and therefore the value of the determinant is 0. So easily we can calculate without expanding. Now some homeworks are given here. You will do. We will get this in PDF. We shall send the PDF also. And this is the end of today's class. Almost everything done in the determinant. Many problems we shall do next classes. And thank you all.